So tonight we're going to learn yet another way of solving quadratic equations, and we're going to do that by using square roots. So solving using square roots is going to require a special situation. And in order for that to make sense, you need to remember that every positive real number has two square roots. One is a positive square root and one is a negative square root. So let's take a look at that. If I multiply 2 times 2, so positive 2 times positive 2, I get 4. But also if I multiply negative 2 by negative 2, I also get 4. So 4 has a positive square root of 2 and a negative square root of 4. So the square root of 4 equals 2, but the square root of 4 could also be negative 2. So we're going to write that as the square root of 4 is equal to positive or negative, so plus or minus 2. So we have the square root property. To solve a quadratic equation in the form x squared equals a, we're going to take the square root of both sides. So what I mean by that is if x squared equals a, I've got an equation written like this, then x is equal to positive or negative square root of a. I've taken the square root of x squared, which is x, and taken the square root of a, bearing in mind that it has a positive and negative square root. So I'm going to try a couple and see how that works. Remember, the square root property tells me that if x squared equals 25, then x equals the square root, positive or negative, of 25. So I know that x equals a positive or negative 5. Let's try another one. Square root property tells me that x equals the positive or negative square root of 16, therefore x equals plus or minus 4. Hopefully that made sense. Let's try this one. X squared equals negative 64. So x equals the positive or negative square root of negative 64. Well, clearly I have a problem here because I cannot, at least not at this point, take a square root of negative 64. So for our purposes in Algebra 1, we're going to say that there are no real solutions. So now, if I have an equation, a quadratic equation that's not in the form x squared equals a, I can still use my algebra to isolate the x squared before taking the square root of each side. Remember SID, we're going to simplify, isolate, and then divide. So let's take a look at that. I've got 9x squared minus 49 equals 0. Well, I'm going to need to isolate. I'm going to have to add 49 to both sides. So I find that 9x squared equals a positive 49. And then I'm going to have to divide by 9 both sides. Remember your SID. So x squared equals 49 over 9. And therefore, to solve using the square root property, I know that x equals a positive or negative square root of 49 over 9, which I will simplify to x equals positive or negative 7/3. So I'm going to let you try these 3 on your own. Pause your video and check back and see if you've got the correct answers. Okay, so hopefully you got that the solution to this first one is x equals plus or minus 9. Here, when I moved the 7 over to the other side, I had x squared equals 0, so therefore x is also equal to 0. This one, I found that x was equal to plus or minus 7/4. So sometimes the number we're taking the square root of is not a perfect square. So in this case, we're going to have an irrational number as our answer, and we're going to just approximate the solution. In most cases, I'm going to ask you to round to the nearest hundredth. So let's go ahead and solve this one. I'm going to have to move my 90 over to the other side, which leaves me negative 3x squared equals negative 90. Divide both sides by negative 3. And I find that x squared equals 30. So my square root property tells me that x equals plus or minus the square root of 30. Well, 30 is not going to be a perfect square, so I'm going to find the nearest hundredth as my answer. So I've got x equals plus or minus 5.48. Okay, and just what you've all been waiting for, your real-world application. Yay! A nursery manager is buying fencing to enclose 3 sides of a garden with 2 short sides and 1 long side. The garden's a rectangle. Sides are 2x and 3x, and the area of the garden is 3,000 square feet. Now, the manager can buy fencing in whole feet only, so we need to determine how many feet of fencing he could buy. Well, if we think about it, the area of the garden has 3 sides. So if we draw a picture of my garden, I've got probably a wall or something over here. That means I don't have to fence that part. And here is the rest of my garden that I'm fencing. I've got short sides of 2x. So my shorter sides are 2x, and then I've got a longer side that's 3x. So I know what my area is, which means I can use that to help me find what x equals. So I know that my area, which is 2x times 3x, right, the area of a rectangle, equals 3,000 square feet. So 6x squared equals 3,000. So I need to solve to find out what x equals. I'm going to divide by 6 both sides, and I find that x squared equals 500. Well, unfortunately, 500 isn't a perfect square, so I'm going to find out that x is equal to plus or minus approximately 22.4. Well, let's think about this. Do I actually have 2 solutions? Well, I can have positive 22.4 feet, but I don't believe that I can have negative 22.4 feet. So I'm actually going to only have one solution, and that is that x is approximately equal to 22.4, and that's that squiggly line on the top of my equals sign that tells me it's about 22.4 feet. Well, to find out how much fencing I need to find out how long this fence is. Well, this fence is 2x plus 3x plus another 2x, so I've got 7x units of fencing, and each time I've got an x, I know that's approximately 22.4 feet, so I'm going to multiply 7 times 22.4, which will give me, and remember we're still approximating because we're rounding. My apologies. This is 156.8 feet, and I'm just going to go ahead and round that to 157 feet of fencing. Here are your questions that I expect you to bring into class tomorrow, but your joke for the day. Why did the Romans not find algebra to be very challenging? Because they thought that x was always equal to 10. Think about it. Write your Roman numeral. We'll see you tomorrow.